Sometimes we talk about strong acids and strong bases. Many people think that when we're talking about strong acids and strong bases, that we're talking about how concentrated they are, and we're not at all. So let's look and see what is a strong acid and what is a strong base. It really has to do with how separated the ions are. When a strong acid dissolves in water, we define a strong acid as being where 100% of the acid dissociates into ions. So if I look at this, if I put hydrochloric acid in water, 100% of it goes all the way to separated ions. Notice when we do this, we write a single arrow in that direction. Okay, those are the strong acids. And how do I recognize what is a strong acid? Well, there's a single arrow, and if I were to draw a picture of it, you would see all the ions separated, none of them stuck together. Common strong acids are hydroiodic acid, hydrobromic acid, hydrochloric acid, sulfuric acid, and nitric acid. You don't have to memorize those. I'm not going to ask you which are the strong acids, or nor will I give you a problem where you have to know which are the strong acids. When a weak acid dissolves in water, what happens? Only a small fraction of that acid actually separates. So if I look here at acetic acid, which is a weak acid, what happens? It breaks apart and makes a proton, an acetate, but there's a huge amount that goes right back. Actually, with acetic acid, if you test to see how much it dissociates, we find that only 5% of it actually breaks apart. So the majority of it is still stuck together. In order to indicate a weak acid, not only do we show the forward reaction, but we show the reverse reaction saying it's going back this way. And you will recognize that when you have a forward and a reverse reaction, we've got an equilibrium. So anytime you have a weak acid, you actually have an equilibrium dissociation. Common weak acids are acetic acid, phosphoric acid, carbonic acid, and there's many, many, many others, but those are three that we will see. And again, I will not ask you if this is a weak acid or if it's a strong acid. I just am letting you know that there are some. A base is just the same way. A strong base will dissolve in water completely and completely dissociate. So you will have, if you make 1 molar sodium hydroxide, there's none of this left stuck together. What is it? It's all separated in solution. This, and we show a single arrow. Common strong bases are sodium hydroxide, potassium hydroxide, lithium hydroxide. Those are some common strong ones. When a weak base dissolves in water, though, again, we have an equilibrium ongoing, and only a small fraction separates. What do we see when we put ammonia in water? We find that only some of it breaks apart like this. The majority actually is left stuck together and not as ions. So acid and base strength is not a measure of concentration or even a measure of how low or high the pH is. What is it? It's a measure of the degree of dissociation. The strong acids and bases have complete dissociation, and the weak acids and bases have incomplete dissociation. So if I look at a picture of this, you can see most of these, if I consider the red to be the acid and the anion, and the little blue to be the hydrogen ion. If you have a weak acid, most of them are going to be stuck together. Only a few will be separated. Of course, in water, you are not going to have this naked. What is it going to be? Attached to a water molecule. But this gets the idea across. However, with a strong acid, all of them become separated. You can see from this picture that a weak acid will be making fewer protons per molecule than a strong acid. Keep that in mind. That affects their behavior.